Hello everyone, how are you going? This is Miss Sue and today we are doing linear relationships. So the first thing that we need to know about linear relationships is the Cartesian plane. So if you can see the diagram over here, so this is actually a Cartesian plane. A Cartesian plane consists of the x-axis, which is the horizontal line over here, and the y-axis, which is this vertical line. And the x-axis and the y-axis actually intersect at a point O. Yeah, as you can see from the point here, this point is a point xy. So we are doing this lesson on an assumption that you understand coordinate geometry, and this point is also called as the ordered pair. Yeah, the point 0, 0 over here is also called the point of origin. Yeah, so today we are covering linear relationship, and we have to know that the word linear actually comes from the word line. So that would mean that this relationship, when drawn on a Cartesian plane, it's going to appear as a line. Yeah, there are many ways to represent this relationship, and the most common way to write it is in the gradient-intercept form, which is in the form of y equals to mx plus c. As we can see here, x and y are actually points on your coordinates. Yep, and c actually stands for the y-intercept. So that's where the line actually crosses the y-axis on your Cartesian plane. And the m is actually your gradient. So this is the formula of the gradient, and of course gradient is also calculated as the rise over the run. So I'll show you what I mean from this example here. So given an example of a line that passes through a point 0.5 and another point 4.1, we can see here that the y-intercept is the place where the line crosses or intersects the y-axis. So the y-intercept will be 0 and 5. So my c will have a value of 5. Yeah, so let's say I set my 0, 5 as x1 and y1, and my other point as x2 and y2. Yep. In order for me to calculate the gradient, I just have to put the values of these pronumerals over here. I have to just substitute these values into the equation. So I know that my y2 actually has a value of 1. So that's why this is 1. Take y1 has a value of 5. So that's why I'm substituting 5 over here. And the same goes for the x values. Yeah. So the corresponding x value for y2 is x2, which is 4. So 4 take x1 is going to be 4 take 0. So that's going to be 4. And if we simplify this, it's going to be -1. So how do we represent this line in a gradient-intercept form? It is actually y equals to mx plus c, and considering our m is actually -1, so that's why it's y equals to -1x plus, because my c is my intercept, which is 5 here, it's going to be plus 5, which is a -x plus 5. So we also need to know lines that pass through the origin, and as mentioned before, origin is actually the point that is 0, 0. So that's over here in the Cartesian plane. So a line that passes through the origin, we have to know that the y-intercept is actually 0, because it will pass through the y-intercept where it has a value of 0, and therefore it's going to be y equals to mx plus 0, or just simply y equals to mx if you're talking about the gradient intercept form. So in this case, if y equals to 2x, you can see that the line will pass through here. And in another example, if y equals to -5x, it's going to pass through here. Yeah. In order for you to familiarize yourself further with drawing lines on the Cartesian plane, let me just introduce to you a very simple software. So you can find this software on in Google. So the software that I'm mentioning is called Desmos. So if you actually entered Desmos into Google or into your browser, you will get this one. This is the one that I'm talking about. It's Desmos Beautiful and Free Math. So click on this. And what you can see is this. And in order for us to start drawing graphs, yeah, as you can see that we can draw many sorts of design here. But let's just say we're just drawing a simple graph. So you can start graphing. Yep. It is also a good idea to sort of like set up an account with Desmos so that you can actually save what you have done before and you can actually share it to your friends or anything. Yeah. So as we mentioned just now, so if y equals to 2x, that was the first graph that passes through the origin. Yeah. So y equals to 2x. So we can see that it's just a graph, yeah, that passes through the origin, which is the point 0, over here. And just now I also mentioned y equals to negative 5x. Yep. So it's going to be another point that passes through the origin. Yeah. And just now we also did y equals to, I think it's negative x plus 5. And so you can see that for this one, because we have a plus 5 over here, like a constant over here, the intercept has a value of 5. Yeah. So the intercept is the point where it's actually where the line crosses the y-axis. Yeah. And these two, the intercepts are 0. So feel free to learn up how to use this or just play around with this. Yeah. So let's just go back to what we need to be doing today. So just now we were here. And okay, the next part is learning different types of gradients. So just now when we were doing y equals to negative 5, the gradient was sort of like sloping down. So we know that when the gradient is negative, it's sort of like sloping downwards. Yeah. So when the gradient is positive, like any positive number or fraction or anything, yes, so it's sort of like going up. It's keeping like increasing. Yep. So what happens when the gradient is 0? When a gradient is 0, the line will just be like a flat line. Yep. So what if the gradient is undefined? The gradient is undefined. It's gonna look like this. Yep. So let me just show you what I mean about this on Desmos. Yep. So if we go back to Desmos, just now we did a positive line. So I'll just remove this first. So just now we did a positive line, which is the first one, y equals to 2x. So as you can see, because 2 is actually positive, can you see that it's like it keeps increasing? Yep. So this is what I meant by it keeps increasing. So what happens if I change my 2 into a negative 2? Let's see what happens. Yep. So can you see that now the line is sort of like it keeps decreasing? Yep. So what happens if, let's say I have a 2x plus 2? Yep. So can you see that just now before I have a plus 2, it's just this line. But let me just draw another line so that you can see it clearer. So y equals to 2x. If I put a plus 2, can you see that now there is another line, but it's sort of like passing through a 2 as an intercept. Yeah. And then what if, like just now what I said, what if the gradient is 0? Let's just try and see what's going to happen. Yeah. So can you see that when the gradient is 0, the line is sort of like horizontal, it sort of like flattens out? Yeah. So this happens when the line is 0. So what do you mean by a line that is undefined? I'll show you what I mean. Yeah. An undefined line is like something like an x divided by 0. So if you see a line that's y equals to x power 0, it is undefined, and therefore you can't sort of see it here. But you can an undefined line could be drawn in another way. I'll show you in a short while. Yep. So let's just quickly go back to this. So just now we were here, we were talking about different gradients. Yep. And then now let's just go to this one. So vertical and horizontal lines. So just now when we were doing the gradient is 0, we sort of get a horizontal line already. Yep. So for example, y equals to 3. We are getting a horizontal line. So the line, the gradient that is undefined actually has x equals to 2 or x equals to something. So when x equals to something, the gradient is undefined. So let's just go back to Desmos and have a look. Yeah. So let's say my y equals to 3. Yep, you can see that it's a sort of like the gradient is 0 and it's a flat line. Yep. So what if y equals to -3? Can you see that now instead of it was 3 over here, it has moved down? Yep. So let's just do a one with the gradient that's undefined. So as mentioned just now, if you want to draw a gradient that is undefined, it's going to be a vertical line. So therefore, x will equal to a number. So it could be any number. So let's say x equals to 5. So can you see now my sort of vertical line is drawn already? Yeah. Feel free to explore further if you need to. And then let's go sort of like to the next part. So the next part, which is actually the last part, is actually parallel lines. Yeah. So how do we get parallel lines? As long as we get sort of like the equation where you can see that the gradients are the same, it's going to be parallel. So this is the one that I just draw with the sort of like the gradient with the values of 2. So you can see that it's parallel. So if we go to Desmos and draw something, so let's say I have y equals to 3x plus 2. Yep. So this is meant to be a plus here. So okay, this is my first line. So how do we draw the parallel lines again? So the gradient must have the same value. So let's say if I have y equals to 3x, let's say take 5. Yeah. So can you see that I actually got another line? They are parallel, and it's just that -5 here means that the intercept will be -5, and 2 here means that the intercept will be +2. So yep, this is the end of our lesson today, and I hope that you understand about linear relationship more, and happy studying at home, everyone. So see you then. Bye.